Hello, Dr. Bishop here. I'm recording this little mini web lecture because if you recall this practice question that we got in class, we decided to give you a little bit more time to get caught up on the material and think about this question later. Turned out we didn't have time to come back to it in class. So I wanted to give you a little bit more information on this question, but also use it as an opportunity to give you some approaches that you can take to answering these kinds of more conceptual, higher order learning kinds of questions. And so what's the question? What would you expect to happen to the temperature on Earth if there were no calcium-containing rocks on Earth at the time when Earth was cooling and forming liquid water? So what are the things, the first thing you want to do is just figure out what the question's about. What are the important parts of this question? So first of all, we want to think about something to do with the role calcium plays, and we want to know its effect on the temperature on Earth. So what is the effect of the presence of calcium on the temperature on Earth at a particular time? We give you this context of the time we want you to be thinking about, the time before life when Earth was cooling down and first beginning to form liquid water. So let's think about these separate things. So we want to know something about the relationship between calcium and the temperature on Earth, or the climate. So where have we seen calcium before? Basically, we've seen it in this cycle here. This is the carbon sequestration cycle. It's in the web lecture on conditions for life on Earth. And so we know that the role calcium plays in this is that when the carbon dioxide mixes with the water in the upper atmosphere in the clouds and rains down this acid rain, that acid rain dissolves a little bit of the rock in these mountains that it falls on. That dissolved material from the rock is calcium ions and carbonate ions, which are then washed down by the rivers into the ocean, where it's sequestered. It precipitates out and forms a rock again, calcium carbonate. And so that carbon has been taken up by this rock and sequestered more or less permanently in the ocean. So that's what we know about carbon. Now, what do we know about the temperature of Earth when all of this is happening? So we know that the Earth started out very, very hot. It was formed as a molten, melted rock, basically, mass that was gradually cooling. At this point, it was often being hit by asteroids, which also made it very hot. But at some point, that asteroid activity slowed down, and basically the temperature of the Earth was just going down just because it was radiating all this heat out into space. And so it was just sort of natural cooling until we get to this point, where we have liquid water. So now we know something. We've reviewed what we know about calcium. We've reviewed what we know about surface temperature. How are the two related? To find that out, let's go back to this concept map that shows you how all of these ideas are related. So here is that carbon sequestration cycle that involves calcium. There's a missing arrow here, but this calcium sequestration leads to a reduction in atmospheric carbon dioxide. But remember that this also has an effect on the temperature. Because carbon dioxide is a greenhouse gas, it's not going to be trapping as much heat and keeping it close to the surface of the Earth. And so that's going to continue to decrease the temperature. In fact, it's going to really, really accelerate that rate of decrease. So if you look in this region here, where all of a sudden the rate of decrease of carbon dioxide just plummets, that is because of this positive feedback loop going from this carbon sequestration cycle to reduction of greenhouse gases, to cooler temperatures, to more liquid water, to a continuation of this carbon sequestration cycle. So what have we done in this question? We have basically disrupted this cycle, okay? This cycle that accelerates that rate of cooling on the Earth by saying that all of a sudden now we don't have any calcium to sequester that carbon in the ocean. So now what's going to happen? Okay, so now we know this relationship between calcium and climate, between calcium and temperature. Let's go back to our question. Oh, there's our arrow. Okay, complete cycle. So then, what would you expect to happen to the temperature on Earth if there were no calcium-containing rocks on Earth at the time when Earth was cooling and forming liquid water? So, multiple choice questions consist of, among these options, one correct answer and some number of what we call distractors. Okay, good multiple choice questions have distractors that sound very plausible. You have to really, really understand the concept, really know what you're talking about to choose the one that actually really works. And so these distractors, the first two things you want to ask yourself about each of them. First, is it a correct statement? If you've got a cause and effect both in the distractor, does that cause really lead to that effect? Is the whole thing internally consistent as a response? And secondly, does it actually answer the question that you've been asked? Many times, especially in very good multiple choice questions that really require you to think, you might get a statement that by itself is perfectly true, but it does not answer the question that's been asked. So let's look at each of these distractors starting at the bottom. Okay, first, there would be no change in the temperature of the Earth. So basically, if we think back to that graph of how levels of carbon dioxide were changing and how the temperature of the Earth was changing, the Earth was already in a cooling process, right? It was already cooling off before we went into this positive feedback cycle that cooled it off very quickly. So there's no reason to think that that wouldn't have continued even if we didn't have that carbon sequestration cycle. So this one is very unlikely. Chances are it would just stay on the same trajectory that it had already been on. It would heat up rapidly due to the accumulation of carbon in the ocean. So let's go to this first one. Is it correct? Is it internally consistent? If carbon is being accumulated in the ocean, then there's less carbon dioxide in the atmosphere. Carbon dioxide is a greenhouse gas. That's going to having less of it in the atmosphere is going to allow the climate to cool. So heating up rapidly due to the accumulation of carbon in the ocean is not even internally consistent. That can't be our right answer. It would heat up slowly due to collisions with asteroids. Well, we've already specified that this is the time on Earth where the Earth was already cooling, so it's no longer being hit with these asteroids. That cannot be the right answer. It would cool off rapidly due to sequestration of carbon. Well, that can't be the answer, right? Because we've disrupted that carbon sequestration cycle by providing that there's no calcium in the environment to combine with that carbon and bind it up in the ocean. So the only answer we're left with is it would continue to cool off just the way it had been doing before, slowly due to the radiant release of heat. So make sure that you really take the time to go through these steps. On the exam you're going to have on Tuesday, there's going to be plenty of time to work on these and to slow down and think carefully. Remember, the steps you're going to go through are, first, identify the things that you need to know in the question. What is the information you need to have? In this case, the information was the role of calcium in carbon cycling and how that affects the temperature on Earth. Those are the two pieces of information that you're going to need to bring back to be able to answer this question. Second, make sure you understand all the conditions in the question. So in this case, we need to restrict our answer to a particular time when the Earth was cooling and forming liquid water. And then as you're evaluating each of these distractors, make sure you've put it to these two tests. Is it a correct statement? Is it relevant to the question asked? Now, what if you end up with two that kind of seem correct? Then you want to go back and really look at the details in the question. Okay, so maybe collisions with asteroids seemed like a plausible answer. The Earth does heat up in response to that. Is there something in the question that will let me rule that out? Well, yes. We're looking at a particular point in time when that's not happening. So I hope these are some helpful strategies for you and that they will help you in thinking about how to study and revise all this information to get you ready for your exam.